It's time for example 3. So let's take a look at what we can do in terms of understanding slope-intercept form. Remember, our slope-intercept form is y equals mx plus b. And what we are finding with our slope is we are finding the rise over run, or sometimes if we have a negative slope, the fall over the run. And what I want to take a look at is this common error here. It is very tempting to think that because we have negatives in our ordered pairs, that our slope will be negative also. Really, the slope and the direction of the slope depends on a set of points. It's not just determined by one ordered pair. What we are going to find is that when m is positive or greater than 0, then our slope is going to move up from left to right. So just like we read from left to right, we will graph from left to right. If our slope is smaller than 0 or negative, then from left to right, we will fall. Okay, so this is positive slope, and this red one is negative slope, and it is determined by 2 points on the line. Okay, so we cannot determine the slope from 1 point alone. With that in mind, let's take a look at how can we write the equation of a line when we are given 2 points. So for example, here I'm given the point -1, -2, and the point 3, 4. Now, one thing you can do is draw a diagram. We can always graph our points. So if I'm going to graph the point -1, -2, -1 on my x-axis and -2 on my y-axis, will be right about here. And then the point 3, 4, I'm going to go 1, 2, 3 points over on the x-axis, and 1, 2, 3, 4 points up on the y-axis. There are my 2 ordered pairs. So if I see this from left to right, my slope is increasing a lot like this one over here. So this tells me my m will be greater than 0, or it will be positive. Okay, so to find the slope, what we need to do is find that vertical change. Okay, so how far up are we going? And then how far over are we going between our 2 points? Okay, and that will help me determine my rise over my run. So that vertical change is what I lifted in green. And I find that by what is the distance from this +4 to this -2. Okay, and then my horizontal change is what I did in blue. And we're going from -1 to +3. Now, the work here takes a shortcut. So I am going to count from -2 to +4, or doing 4 minus -2. We subtract our y coordinates, and that gives me 4 plus 2, because minus a negative is positive. That gives me 6. And then I'm going to do 3 minus -1. Okay, remember, minus a negative becomes positive, and that gives me 4. So my slope is 6 over 4. So we're going up 6 over 4. Now what we will want to do is reduce our fraction. 6 and 4 are both divisible by 2. So I'm going to reduce that to get the 3 over 2. And that's where the slope came from. Okay? All right, that's our slope. We now know this, but we don't know our b value yet. I could try to sketch this, but it might not be exact. Okay, it's not going to be perfect if we sketch a diagram. We can't eyeball this, but we can use some algebra. because we know some information here. We know now that our slope is 3 over 2 times x, and I need to figure out my b value. And I just happen to know 2 points on my line, which both give me an x and a y value. So I can replace the x and the y with one set of my ordered pairs. I'm going to use the positive ones just because I do like to keep things positive. So I'm going to use 4 for the y value. And I'm going to use 3 for the x value. Okay. So 3 halves times 3. And then we will solve for b. So 3 halves times 3, if you use your calculator, I'm going to do 3 times 3 to get 9, and then 9 divided by 2 is 4.5 plus b. So then I can use my equation solving skills to subtract 4.5 from both sides, and we end up with b equals negative 0.5. And it's totally acceptable to have a b value that is negative and that is a decimal. So when I put my equation together, we get y equals my slope of 3 halves times x and my y-intercept of negative 0.5. Okay, so that seems like a lot, but do you see how drawing a diagram can be helpful? What I would like you to do is try one on your own on the next page, and I will give you some tips. So here, again, we're given 2 points. So let's sketch that out. Okay. So I draw my y-axis and I draw my x-axis. And I have 5, 4, so 1, 2, 3, 4, 5. 1, 2, 3, 4. So here is 5, 4. Well, that's terribly written. Let me rewrite that. 5, 4. And then negative 1, 6. 6. There we go. Negative 1, 6. So now, again, I can determine my rise or fall and my run. So I want to look at that information. Okay, so what is my slope? Well, we're going from 6 to 4 on the y-axis. So from here to here. So that is down 2. So 6 minus 4 is negative 2. And then my run, I'm going from negative 1 to positive 5. So we're going to do negative 1 minus 5, and that is a distance of negative 6. Negative 2 over negative 6 does reduce. First, we have a negative over a negative. And what is a negative divided by a negative? Why, yes, it is a positive. And then we're going to reduce 2 over 6 because each of these are even. So we can divide by 2, and we get our slope equals 1/3. So I am on my way to having my equation, y equals 1/3 x. Now I need to find my y-intercept. So what are we going to add on to the end here? So remember, we can take either of our ordered pairs, and y equals 1/3 x plus b. And I'm going to pick the one that has positive numbers because, again, keep it positive. So 1/3 times 5 plus b, and then solve your equation for b. Remember, we multiply across the top and across the bottom. So we get 5/3. 4 equals 5/3 plus b, I would recommend changing that to a decimal and getting an approximation. All right, but use those equation solving skills to finish this up.